Hi, my name is Stuart Williams. I work for Magenic, and here's another episode of Web APIs. This time we're going to explore Swagger first design, which is to say starting your API project by designing the interfaces and contracts, so sometimes known as contract first design or contract first development. Once again, we're using editor.swagger.io, into which I've loaded the classic people API I often use during the demos. And I wanted to go through the elements of YAML, and then we're going to look at the generated server. In this case, I chose nodeJS, and we'll walk you through some annotations for that. And all of this is available on GitHub, so you can pull it down for yourself and take a look at it. I love Swagger. I think it's great. I think doing your Swagger definitions in YAML makes sense. YAML's a lot more human readable than the equivalent JSON, although you can certainly get the Swagger editor, editor.swagger.io, to render you the JSON equivalent too. But for our purposes, we're going to be doing things in YAML. A lot of things are far less than obvious, and because they're far less than obvious, I want to highlight some key things along the way in designing your Swagger. First of all, we're going to spend just a second and look at one of the sample JSONs that my API is going to return. And normally we get these out of a MongoDB or a SQL Server or whatever. For the purposes of this demo, we're just getting them off the file system out of a folder. And that's just a shortcut to make the project as simple and easy to understand as possible. We'll go to the data folder, and I'll just show you one of the 10 data files. This is not a particularly great way of viewing them, so I'll show you a little power trick. JSON lint, here is our JSON file, and when we say validate JSON, it also pretties it up for us, as well as checking to make sure that our JSON is valid JSON. So let me walk you through this. This is a person object that is generated by the Data Maker tool, also up on the GitHub. And the person has a underbar ID primary key, which is a GUID. It has a first name, a last name, an email, a couple of dates, and a collection of addresses. In this case, this particular person has a single address, and it has some attributes. And then we have an array of preferences for this person that are code generated. This is just dummy Latin. The important thing about the preference collections, though, is that it is a hash map or dictionary. So it has a name and a value property. And so we're just going to walk through it top to bottom. And as we do, I'm going to point out some things to you that I think are worth doing. The first is there's a general info block. The info block contains, useful properties. In this case, it's got my email. For this demo, I made it the MIT license, and I provided a URL to opensource.org. The next property is very important. It's called the base path, which is all of the API endpoints we're going to declare lower down are relative to this path. So the fully composed path would be /v1/whatever. This is important because if your API needs to version, this is one of the most popular ways of versioning rest of APIs, which is to bury the versioning information actually in the URL itself. And then we have some tags and some links to some external documents and some schemes. Here I have just HTTP, but you could add HTTPS to this list if you wanted to. And in this case, what the important thing is to look at the top block that is in the resulting generated Swagger document and see how these elements relate to that. And the easiest way to do that is, as you make a change and move the cursor off that line, you can see the corresponding change happens on the right-hand side. So that's extremely handy. So after the info block are the paths block, and the paths block are the actual URLs that people will call in order to execute your API functions. Like all good restive designs, it's important to put some thought into your path design. And here, for simplicity's sake, we're going to expose two endpoints, one that gets a list of people and one that gets a specific person by ID. Let's start with the /people all by itself, which returns a people list. Couple of things to notice here. And then you can see here's our URL as /people. Here is the description field, gets a list of people. Here is how it appears in the list. This took a while to figure out, but the tags property is actually how it will show up in the Swagger itself. So whatever you put in here shows up there. There is some additional description fields, but here is the absolutely mission critical thing in terms of naming. And it's this, OperationId. When you use swagger.io to generate a server, which is what we did for this lab, what you end up with is a very small Node and Express project with Swagger added in, and we're going to walk through that code that's generated in a minute and explain it, parts of it. But OperationId is the string that represents by convention what method in what controller should be called in order to implement the URL get/people. So if you get this wrong, you're going to get a bunch of errors that say that it can't find your endpoint. And we'll show you how you can debug this in a little bit. Then there's some metadata about what it consumes. In this case, we've specified that it produces JSON. We've specified a response that says if we get a good response, that means it's a successful operation. And we say that what it returns is a reference to this object. So this says, go look elsewhere in the document. So # here, the definition section of this document for this object named people. Likewise, /people ID, and notice that set a single curly brackets to call out what the parameter is. And notice again that we had to pay very careful attention to the OperationId property. So it's going to look for the people ID controller, and it's going to invoke the method getPersonById. And it's going to produce JSON, and it's expecting a parameter of people ID. It's expecting to find it in the path. So you can see over here on the right, /people/people/people ID. So that would be the GUID in the path. You can also specify that you want things in the query string and so on. And then obviously you can have as many parameters as you need. But for this example, we kept it simple. We can specify that it's required to be there. This case is very important because like all things JavaScript, this is intensely case sensitive. And of course, it says the parameter is a string. Most things in Swagger are a string, and then you can subclass or explain to the consumer that although you're expecting a string, that really it's a date, it's a number, it's a whatever. There are actually very few types in the Swagger spec, and so you subclass them. And in this case, we say that a successful return is going to be this document's definitions person object. Notice that above we were responding this document's definitions people, right? So that's multiple, and this is the singleton. So how does that work? Well, it works because there's a definition section, and the definition section defines all of the models used by your API. So in this case, our first definition is people, which are description property. By the way, adding description isn't required, but gosh, it's a friendly thing to do because the descriptions will show up on the right-hand side so that as we look at them, you'll see the narrative that goes along with that. And if they're trying to figure out your models, it's really nice to put a description on each one, and it, along with the type information, will be displayed on your Swagger page. So please do, as a best practice, supply descriptions. The people object is a type of an array whose items are individual people. In other words, we're going to get back a list of people. Here's the person type. Person type is an object. It has a required field of underbar ID. It has all of the properties that you expect that match the JSON document we supplied. Here we're showing it in JSON lint, first name, last name, company. Again, intensely case sensitive, so make sure that your data is all regular and that you pay attention to the case sensitivity of members, for example, member since. And again, it's nice to provide a description. Notice that member since in our document is a date and a time, but notice since JSON encapsulates these into a string, we need to tell Swagger that, in fact, although its type is a string, what we're expecting is a date time. So you can see repeated that for birthdays. If you have an embedded collection of things, that's no big deal. Here we have addresses, and again, we'll go look at the JSON. You can see that we have an array of address objects. So that's what we tell it. We say addresses are a list of addresses, type of an array, whose items are this document's definition's address object. Here we have the preference. So again, we'll take a look at that. And you can see that that's a collection of name-value pairs. Notice it's not an array. This is intended to be a hash table, whether that's a dictionary object in .NET or a JavaScript object that's a hash table. This is the format for that. So we have to do something a little bit special there. We say that preference is an array, which is the substitute for any kind of a list in Swaggerese, whose item definition is definition setting. Here's address, all the things that you might expect. Again, we're being good citizens by providing a description and a type. And for our setting, we can see that the description is setting and that it has an additional property of type string. So now that we have this relatively simple Swagger, we can go in and say generate server and pick one of these. And in fact, we picked nodeJS server. Here is my Microsoft Visual Studio Code project. What was code generated was a folder called Swagger CodeGen that keeps track of the code generation version. The API folder contains the actual same Swagger that we saw in the editor. It generates a controllers folder. We'll return to that in a minute. But essentially, you can see that we have a people ID and a people list folder. Why is that important? Because in our YAML, we can see that the operation is looking for a controller named people ID in one case, and another controller named people list. We're going to show you how the glue sort of works. And then inside of the people ID, you can see we export a method called getPersonById. And in the Swagger YAML, you can see we're expecting getPersonById. I made a little data folder and put 10 people into it that we made with our data maker. We obviously need a node modules folder that was created for us when we did an npmi and installed all of our modules and their definitions. Now, here's the actual implementation that's generated. And it's generated empty, and I actually populated it with code. When the generator first generates the code, it actually puts these services in the same folder with the controllers. I didn't happen to like that as an organizational thing, so I created a services folder and moved the services into the services folder just because I'm irrepressibly tidy. So if we go look at the people list, you can see that my require statement is up a directory, down to the services directory, go get the people list service. Other than that, the generated code is exactly as it was. In short, we expose a people get method that's expected in the controller, and we invoke our service, people list, which really I should have named people list service. But again, this is the code generated name, and it invokes the people get method into which it passes request.swagger.params, the response object, and of course the traditional next object. And people ID controller is very much the same. Again, we made the people ID services people service, and we made it export get person by ID. So this matches our contract, right? People ID underbar get person by ID. And then we have the normal dross of a generated node project, git ignore, npm ignore, and so on. Let's go ahead and look at the generated index file, which actually starts the whole thing running. Invoke the constructor on connect, which is a popular library for nodeJS. We create a Swagger tools object, which was added as a package JSON dependency. You can see actually that there are very few things that are required. We need connect, we need the YAML parser library for JavaScript, and we need the Swagger tools. That's it. There isn't much in the package JSON, and that's a pretty great thing. And we would create an instance of the parser. I rearranged the code slightly because the generated code, while perfectly fine, didn't expose the things I wanted the way I wanted them exposed. So in my case, I put the server port as a variable at the top. We have different Swagger router configurations, and we'll talk about that in a second. Swagger, and here let's go ahead and just start the application in debugging mode. You can see it helpfully even tells you where Swagger UI is, so let's go look at it. So this beautifully created Swagger output, you can see looks just like the one inside the editor, and if you watch the version we did on Swagger for ASP.NET Web API 2, you can see this looks virtually identical. And in fact, I can click try it out, and it will show me the curl and the request URL, and it'll even show you the response body that it got back, and so on. And I can grab one of these IDs, and I can go and I can invoke the person get by ID method, and I can expand that operation. And you can see that because I made the parameter required, it's required in my thing. I can paste the value into it. I can click try it out, and you can see I get back that person, right? So my API is working front to back. The first parameter is this thing, which is underneath the covers, the Swagger UI takes the YAML that we have and actually generates a Swagger JSON that's consumed by the Swagger single page app, right? This is actually a little SPA that's injected into your generated code, and it needs a JSON file to chew on. And so the library actually transpiles, so to speak, your YAML into JSON, and then injects it into the file system and path, so that if we wanted to see the raw JSON, we could. Now, that only works because the Swagger library is intercepting that call and then transpiling the loaded YAML into JSON and then spewing it out. Where does this Swagger JSON live? It's going to get put into the root, and when the Swagger UI is dynamically generated by the Swagger library, it is going to inject that path into there so that the SPA of the Swagger UI knows where to find the all-important Swagger JSON file. The second thing is we need to tell Swagger where to find the controllers. And again, by convention, we make a controllers folder, and we have 2 controllers in the folder. And so what will happen is when the app starts, it will go in and look for all of the controllers. So what makes this a controller? Supports a function, function's got a particular signature, and it's in the controllers folder. One of the reasons that I moved the services that were generated out of the controllers folder was early on I had some problems with the generated code getting confused as to what was and was not a service. So by separating the controllers and the services, not only do I obey my need for a certain amount of exactitude in terms of how I like to lay out my node projects, but I make it clear that the only controllers are in the controllers folder. We set a global app base to be the root of the running directory. We use it in some of the controllers later on. Now we need to go and get the YAML from the file system. And again, the generator project put it in the /API folder. So now we have the spec object contains the text of the YAML, but we need to transform that YAML into a Swagger doc object. We take Swagger tools, we call initialize middleware, we pass it in our now safely loaded object, which was made from the YAML, and we inject its function. So the middleware object is injected, and that middleware object is what we're going to use to set up our app in the same way that Node developers have been setting up apps forever, and that is we say app.use, and in this case, what are our plugins that app.use is using? Well, it's using the Swagger middleware object. So we need to call Swagger metadata first. That builds an in-memory model of our service API that will be used by the rest of the tool chain. We want to make sure that we inject Validator. So anything in our YAML that said that is required, it enforces all the types and all the other rules we put into our YAML. We need to set up all the routes for our app. And it's going to do that by creating a Swagger router object, which underneath the covers is going to parse the YAML we loaded, go look in the controllers directory, and by convention, mesh the URL that we specified, e.g. /v1/people, to the appropriate controller and its exported method. And then lastly, we have to create the Swagger UI. And then lastly, we call our old friend HTTP create server, which is going to listen on the port. And in this case, the code generator also threw in a happy note that the Swagger UI page has been anchored to the route /docs. Here is the Swagger, and if we wanted to, we can invoke the method straight from the browser, in this case because they're gets and they're easy to do. But if you had puts, posts, deletes, patches, etc., you could use your favorite tool. I happen to like Postman and Fiddler, and notice I can invoke that and I get a nice list. Okay, let's stop the music in code. We're going to drop to our git bash prompt and paste in this little command. So we're setting an environment variable or two, and then we're telling Node to start. And the great thing about that is that the Swagger middleware will emit debugging information about the paths that it found from your YAML. So from the YAML, it found /people, /people ID. It enumerated the controllers folder, and it found people ID, get person ID, right? How did it find that? peopleid.js, that exported get person by ID. Notice this is intensely case sensitive. And because our YAML specified that this thing goes with that thing and this thing goes with that thing, notice they're not in the same order. They're discovered in whatever order they're discovered in. It will invoke the right method in the right controller for the right path. So you can see this is a beautiful debugging output. And if we go back to our thing, we can see that it's rendering the same result. We can go to docs. You can see it's rendering the same result. The only difference is that instead of running out of Visual Studio Code, it's running out of the console. And what's really cool about that is notice that as each of the pieces of middleware is executed, it's actually showing you the resolution of the routes and all of the things that flowed across the wires. So when it served up the Swagger UI page, the Swagger UI page needed a bunch of resources. And so the middleware is showing you that, in fact, it's going to get them all. And so let's take a look at this. We'll scroll all the way down to the bottom, and we'll invoke one of the methods again. In this case, let's go ahead and invoke the people list, and we'll say try it out. And we'll go back to our console window and notice that you can see that it got whack v1, whack people. Why whack v1? Because that was our base URL, so all the other URLs are relative to it. Whack people got processed. It said, yes, it can process this request. Notice that if you had other types of routing, regular node routing and stuff, Swagger will take the first shot at it, and then if you had additional routes in your route list, it would try to do those. So if it's unable to resolve the route, it invokes next on the next route handler, assuming that it will get handled. And notice that because it said it would handle this particular route, that it said what the specific route handler it tried to invoke was. And this is how we can debug the routes at runtime. One of the other things that turned out to be more challenging than I had sort of initially hoped was reading things off the file system asynchronously is not the most obvious thing in the world. Here is people ID service, which is invoked by the people ID controller. And in fact, we're doing a read file off the disk of the data by composing the file name. So we're using path.join to compose the application root of the file system to the data folder, and then we're taking the incoming people ID value and gluing it to .json, and the resulting file name is getting read. That data is getting parsed from JSON into an object, and then we're stringifying it back by calling resource add. That may seem a little odd to you, but if you don't do this double bounce, in other words, reading the file off the file system, parsing it, and then stringifying it back, what you get is very peculiar looking JSON. JSON with the quotes escaped, and JSON that's malformed, and so on. So a couple of key things about reading JSON off the file system in Node. One is you need to specify the encoding. Super critical. In my case, I'm running Windows, but if you're running Linux, it's the same thing. Do specify the encoding of UTF-8. If you don't specify the encoding, what you get back is an array of bytes. Less useful than just a big blob of text, which is what we want. And second, it's really super helpful to set the header content. And again, in my case, I'm going against the file system so that the demo is self-contained. But you could then npm in your favorite libraries to go and get data from Mongo or SQL Server or another web service or whatever you wanted. But the resulting generated code is basically pluggable and ready to use.